Hi guys, welcome to another video of Physics 2. In this case, we're going to start with a new topic. In this case is dynamics. If this is your first video, well, this is a series of video that is in a playlist, so I recommend you that you follow that playlist. Okay, so what is dynamics? If you remember, in the previous videos, we got problems where the objects were already moving and we only care about finding velocities, distance, the time, or the acceleration. And just in a few problems, we focus on finding the forces. Okay. Now in these problems, we are going to focus on finding those forces that produce motion. Okay. So this is the problem number one. Okay. So in the problem number one, we got a surface, an horizontal surface, in this case could be the floor, and we've got a block which mass is 10 kilograms. And this block is being pulled by, well, there is a person over here. Of course, I didn't draw the person because I'm not a very creative person. But this person is pulling a block with a rope. It could be a rope. And the force that this person is using is 90 newtons. And the angle between the force and the horizontal is 50 degrees. Now, there are some questions that we need to answer. The first question is, what will be the acceleration, okay, of this block? What is the normal force and what is the distance traveled in 10 seconds, okay? In a moment, I'm going to define what the normal force is, okay? But this is how we identify the normal force. Okay, so every time that we have these kind of problems, I mean, they are going to have the same structure. I'm going to have the drawing. Now, the very next thing that I need to do is the free body diagram. I'm going to write it over here. Free body diagram. Or if later on, I'm going to be calling just FBD, free body diagram. And the free body diagram is just a representation of my body using a Cartesian plane. So I'm going to draw that Cartesian plane. Okay, something like this. It doesn't, I mean, we're not going to write numbers, so it doesn't matter if it is kind of exact or something. Just to mention that this is the x-axis and this is the y-axis. Okay, now in the middle, I'm going to draw a dot. In this case, it's going to be this dot is going to represent the block. It's like a particle, so I'm going to use just a particle to represent the block because I don't care about the dimensions of the block. If you see, I didn't tell you how many meters width or height. So in this case, it doesn't matter. I'm just going to represent that block with a dot, a single dot, and that will be my particle. Now I'm going to draw all the forces that interact with that block. Okay, so even though the problem does not mention that force, there is a force that there will be always there, because if the object has mass, we're going to have that kind of force, and that force is going to be the weight. Now, if you remember, the weight always points to the center of the earth. In this case, will be pointing down. So that is the particle. So I'm going to draw that the force, the weight is this one, and it's pointing down. This is the weight, okay? And then I'm going to draw the force that is being used to pull the block. Okay, this is the force. But I don't want this force. I want to decompose this force so I can have the force in x-axis and y-axis. So in order to do it, just remember the definition. Every vector has two rectangular components. So I'm going to decompose this vector into two rectangular components. So I'm going to have fx and fy. Those that topic we already saw it in the first videos. If you don't remember, well, I recommend you to watch them. Okay, so if you see the force points to the right and points up, so fx will be pointing to the right. This is fx, and this one is fy. Okay, I repeat, I just decompose this force over here in the two rectangular components. Now let's talk about the normal force. This one over here is the normal force. Normal force. Now, what is the normal force? The normal force is going to exist every time that our body is in touch with a surface. So in this case, the surface is the floor and the body is in touch with the surface. Okay, so that means that in this case we're going to have the normal force, and there is a definition. The normal force must be perpendicular to the surface. So if you see this is 0 degrees, so the normal force must be in 90 degrees or 270 degrees, and also must be opposite to the weight. Okay, so do we have a surface? Yes. So the normal force is perpendicular to the surface and is opposite to the weight. And this is going to be the normal force. I'm just gonna draw it with green, and this is the normal force. Okay, I repeat, if we got a surface and the block is in touch with that surface, we're gonna have normal force, and the normal force is opposite to the weight. Now, what is the definition of the normal force? The normal force is just like a reaction force. Just like the Newton's third law, every action force has a reaction force. So when you hit the wall hits you back. That's why it hurts. And that is exactly the case. There is a force that pulls you to the center of the earth, that is the weight. But the surface is going to throw you with a force, but with the opposite direction. Okay, of course you don't go away flying, because those two forces are in balance, they're in equilibrium. Okay, so that's kind of the definition of the normal force. Now, after I got my free body diagram, okay, I'm going to begin with the analysis of my free body diagram. So in order to do it, I need to take into account the reference system. Remember that in reference system, everything that goes right is positive, left is negative, up is positive, and down is negative. Okay, so I'm going to begin with the analysis. Remember, this is two-dimension, x and y, so I need to do both analysis. First, I'm going to begin with y-axis. You can begin with the x-axis, it doesn't matter. Okay, so I need to see the drawing. So this person is going to be pulling that block, and the motion, the direction of the motion will be this one. That will be the direction of the motion. And it is important to consider that in this problem there is no friction. We're gonna see the problem with frictions later on. Okay, so the direction is horizontal. So that means that there is no motion in the y-axis. I mean, the object is not moving in the vertical axis. And I'm going to use this formula, force equals mass times acceleration. But of course, I'm going to decompose that force, so I'm going to make the analysis in x and y. So the analysis is going to be the sum of all forces in y equals how much is the body going to move in the y-axis? No, it's not going to move. If it's not going to move, okay, so it's going to be 0. the sum of all forces in y is 0 because the object is not going to be moving in the y-axis. I repeat, and that this is very, very important. Okay, so I need to consider the forces in the y-axis. So how many forces do I have? Well, if you see, I got the weight, I got the normal force, and I got the Fy. So which one are positive? Well, normal force is positive because points up, and Fy is positive too because goes up. And the only one that is negative is the weight because it's pointing down. Minus weight equals 0. Now from this equation I need to find the normal force. So I'm just going to isolate normal force. So normal force equals weight minus Fy. Okay, so I'm going to write the equations to find Fx and Fy, and these are equations that we already know. Fx equals the force times the cosine of the angle, and Fy equals the force times the sine of the angle. I repeat, those are equations that I already know, and the weight equals the mass times the gravity. Okay, so normal force is going to be mass times gravity minus the force times the sine of the angle. Now let's get a calculator. I got it over here. So I'm going to do the mass, that is 10 kilograms, parentheses, 10 times the value of the gravity. Now it's very important. In the previous problem, we treat gravity with negative sign. In this case, we are not going to do that. Why is that? Because if you see in this equation, I already gave the negative sign of the weight. I'm making the weight negative because the gravity is negative. So if you use gravity and you use then the negative sign, the problem is not going to be correct. Okay, so again, I'm going to use the gravity with the positive sign because I already use negative sign here in the weight. So let's continue. 10 times 9.8 minus the force, and the force is well, parentheses, 90 times the sine of the angle is 50, parentheses, parentheses, equals, okay, that is the value of the normal force. So normal force equals 29.05 60. Remember, we're talking about forces, so it's newtons. So I'm gonna circle this, and that is the normal force, that is the reaction force. And if you see, the forces are in balance. That's why the the object is not going down or it's flying away. Okay, and this is letter A. Okay, now let's make the analysis in the x-axis. Remember, we need to make the analysis in both axes because we have 2 dimensions. So x-axis. So the first question, is the body going to move in the horizontal axis? Yes, it's going to move. And they ask me for acceleration, so that means that the body is going to have acceleration. So the sum of all forces in x equals mass times acceleration. It is the same equation that I have over here. Okay, so I need to look at the forces that I have in the x-axis. So if you see, there is only one, and is Fx, and points to the right. So if it's pointing to the right, so the force is going to be positive. So the equation is going to be Fx equals mass times acceleration. From this equation, I'm going to isolate acceleration, that is Fx over mass. And remember that Fx is the force times the cosine of the angle over the mass. So let's get the calculator. Fraction force is 90 times the cosine of 50 over the mass over 10 kilograms equals, okay, that is the acceleration. Okay, remember that this must be in newtons and this must be in kilograms, so the acceleration is in meters per second square. So acceleration equals 5.78 50 meters per second square. I'm gonna circle this one. I'm gonna save it in my memory A of my calculator, Shift STOA. Okay, so this is letter B, and I save it because I'm gonna need it in order to solve the letter C question. So what is the distance traveled in 10 seconds? So if you see, for example, the block is here at the beginning, okay? And 10 seconds later, the block is here, okay? So in here, I got the initial velocity. The initial velocity in this case will be 0 meters per second because I'm going to start moving the object. The initial position is 0 meters. In this part over here, I got final velocity, which I don't know. I got the final position, which I don't know. The only thing that I know is the time, that is 10 seconds, and the acceleration, that is, how much was? 5.78. 5.78 meters per second square. Okay, so I need to find the distance traveled. So I need to find the final position. So I'm going to write the equation for final position. So final position equals initial position plus initial velocity that multiplies the time plus acceleration that multiplies the time raised to the square over 2. I'm going to cancel everything that is 0. Initial position is 0, initial velocity is 0. So this is the equation that I'm going to use. Acceleration that multiplies the time raised to the square over 2. So let's do it in the calculator, okay? So fraction, the acceleration, I just got it in A, times how much is in times 10 seconds raised to the square over 2, and that will be the distance. My God, that's a lot of distance in 10 seconds. Okay, I need to tell you that, okay, it has to be a really superhero or super powerful person, and it's obvious that I just made this problem up because this acceleration is so big. Okay, in each second the velocity is going to increase 5.78 meters per second. So okay, just don't believe that this is kind of true. Okay, my mistake, sorry. 289.254 meters in 10 seconds. Okay, I'm just gonna try next problems, try to do them closer to reality. Okay, so this was the first problem about dynamics, very important. In this problem, we are not considering the friction. And well, this is the easiest problem. If you didn't understand, don't worry, we're gonna see a lot of problems and I hope you understand them. Okay, see you in the next video, guys. Bye bye.